Good evening, my name is Jordan Wagner, and my presentation is on biomass power plant. So my objectives are: what is biomass, what material is used in a biomass plant, what is a combustion conversion, what is gasification conversion, and conduction, convection, and radiation. So basically, what is biomass? Biomass is the use of plants or animal materials as a source of fuel. Photosynthesis, of course, how those plants actually grow, is the process of photosynthesis as the sunlight and the plant basically takes that sunlight and converts it into oxygen. So components over the actual facility itself that we're going to be looking at is the boiler, the fuel source of what's going to be put into that boiler, heat exchanger, steam turbine, generator, and what thermodynamics actually occurs in that process of conduction, convection, and radiation. So basically, our types of biomass, I classify them in three groups: wood, garbage, and crops. The landfill gases are in the subsection of garbage, and the alcohol fuels are in a subsection of crops. So basically, of course, our types of biomass are for wood, firewood, sawdust, wood chipping, pallets, etc. Anything that's wood base is going to fall into this category. Garbage, anything that we throw away as humans, paper, wool products, wasted food, clothes, cardboard, anything that you can think of that's going to go in the trash is going to fall into this category. And then that subcategory of landfills, basically anything that we can put in a landfill, cover it, and hopefully it will emit some type of gases. I think they mainly methane gas is what's going to produce, and then it's going to go over to an extractor, cleans it up, and then it's going to be used in a gas engine. Crops, so our farmers that they produce, we have corn, soybeans, switchgrass, algae, sugarcane, and most other types of crops, and this falls into making that the alcohol fuel. Going through that process through breaking it down and converting it over into an alcohol or an alcoholic based fuel source. So, and I got this quick little video to watch.
Renewable Energy 101. Biomass, the original renewable energy. It's been part of our lives since our ancestors learned to control fire. In fact, it's made possible by the sun, whose energy is absorbed by trees and plants through photosynthesis, and then released when organic matter is burned or decomposes. First, there's plant waste. Wood scraps, sawdust, and crop waste can be collected from farms or manufacturers. The waste is burned to heat water. The hot water creates steam. The pressure of the steam spins a turbine. The turbine powers a generator. The generator creates electricity. Simple, really. Next up, animal waste, also known as the problem of cow poop. The solution? Waste from farm animals can be collected in a large tank called a digester, filled with bacteria that eats the waste and converts it to methane gas. The methane is captured and burned to heat water and create steam. Sound familiar? Second verse, same as the first. This same principle can also be used to capture methane, a potent greenhouse gas with 25 times the heat-trapping ability of carbon dioxide, from landfills. Once a section of the landfill is closed off, pipes are run from the waste to collect the gas, which can then be burned to make electricity or heat. Biomass may not be the prettiest form of renewable energy, and it needs to be used carefully and thoughtfully to protect ecosystems and prevent greenhouse gas emissions. But it can be a smart way to make use of waste. Power to the poop.
Sweet.
Renewable Energy 101.
So now we're moving on to combustion conversion. So what is combustion conversion? Basically, it's the mean of generating energy from combustion of fuel. So those wood chippings, those pallets, anything that we can throw in that's going to get burned off as our fuel source is going to fall into this category. In this process, of course, we see that it is a process that creates radiated thermal radiation heat. So in this one, energy emits from burning off the biomass fuel source, like I said. So gasification uses steam and air. trying to break down the materials, the biomass that is going to be put into this chamber. It's going to be heated up without burning it, of course. It's basically just going to be kind of like breaking itself down and emitting gas. And from this, you can make diesel, um, and some other type of gases from this. All right. So thermodynamics is the relationship between heat, work, and energy. Of course, we kind of know this by taking this course, and it's that transfer of heat from one object to the next, basically in a given time. So, moving on over to convection. So, convection is the process by which heat is transferred by movement of a heated fluid such as air or water. Conduction is the process by which heat energy transmit through collision between neighboring atoms or molecules. We did this in that one experiment in the lab. We can all relate to this. Radiation is thermal radiation, or thermal radiation is electromagnetic radiation generated by the thermal motions of particles in matter. As you can see, the diagram of the fire giving off radiation heat towards those hands. And then just to sum this all up and break it down, so biomass, we have our fuel source going in. This is more of a combustion base, not a gas base. So the fuel source going in, creating that radiation heat, that's going to heat the pipes. The pipe then is going to go through conduction from a solid object heating from the pipe being hot. It's going to heat that water. That water is going to be mixed between hot and cold. It's going to have convection, heat on that, and then in that process with that heated line, it's going to create steam. That steam is going to go down to a high pressure boiler. More or less, it's going to get heated to a higher temperature, and then it's going to be pushed through that turbine down there. And once it's spinning that, of course, it's going to spin that generator, producing power. And of course, we have that heat exchanger. That's going to be that cycle between that hot and cold.